ration. All right, so today is 6.1. It's a relatively short lesson. So the name of this chapter is Inverse and Radical Functions in Relation. We don't do inverse, so notice that cuts out a lot. We're not doing 6.2. We do very little of 6.4, 6.5. Like, we're doing a very light version of chapter 6. Okay. Quiz is Tuesday morning. We got to be ready for that. Idea, we got to focus at the end of class, knock out our homework and our Alex. Not trying to overwork you, but I feel like this is a doable lesson. Operations on functions. So in chapter 5, you subtract and multiply and divided polynomial expressions. The same operations and others can be formed on functions. So notice, if you, the addition, right, f plus g of x, all that means is you're adding the first function to the second. So what this looks like is you're just adding the functions together. So that was our quick poll from today. Similarly, if you're doing f minus g of x, guess what? You'll be subtracting them. F times g of x, you're multiplying, and f over g of x is dividing them. No, because it's function notation. Because each of these are a function in terms of x. And that's why we have to have the x.
So like at the end, you do like whatever the answer is, parentheses x?
No. Nope, not at all. It's the way it's written. Like why do we put a question mark after what? Like what? Question mark? What? Like why do we do that, you know? That's the notation. We write a question mark so you know it's a question. We write a parenthesis x parentheses so that way we know they're functions and not variables. That's why we do it. That was actually a good example. I gotta remember that. Oof. Okay, so let's try the first one. F of x is blah. G of x is blah, right? You can see that. So if I'm trying to take f of x, f plus g of x, honestly, the translation's what's going to trip you up. That and not doing, like, combining like terms correctly. Literally, it's the Algebra 1 skills. That's really where you're going to mess this up because it's pretty straightforward. If you see the plus sign in between them, you're just going to be adding your two functions together. So we can go ahead and add. F of x is 3x squared plus 7x. G of x is 2x squared minus x minus 1. And if I add these together, combine like terms, I get 5x squared. 7x minus x is going to be 6x. And then minus 1. And that's it. That's it, right? You've done this before. It's just a different way of approaching it. You've done this line in purple. We did this all night and day last chapter, but the difference is now we're going about it a little differently, right? Function, the actual formal notation. And then you plug in and that's all. Okay, let's do the next one. What is this next part asking us to do? What is this next one asking us to do? F minus g of x, what are we doing? Subtract the two functions. Subtract them. This is the same thing as saying f of x minus g of x. So, parentheses are your friend. Don't forget them. So I'm taking 3x squared plus 7x and subtracting my g of x. Now, this is the first thing people mess up on. They will take 3x squared minus 2x and they get x squared. And then they take negative, they take 7x minus x and they say, oh yeah, that's just 6x. What did I do wrong? You have to distribute the negative. Oh my gosh, ask me how I know. I grade your homework. This is what we do. This is the mistake. You must distribute the negative and then you can combine like terms. Distribute the negative and then combine like terms. Yeah. Yeah. You gotta distribute that negative. You gotta. Otherwise, oh my gosh, you're gonna be missing problems. If you don't distribute that negative, there's a hot shot that you're going to miss the second and third terms where you should have distributed the negative. Because people forget, if the negative's right now, if it's not next to the number, they forget about it. So I'm trying to show you where people make mistakes, so that way you don't make those. I don't want you to make the mistakes. Okay. So far, so good? Hey, okay. So, idea is we will finish this page, we'll do 1 or 2 examples, and then it's just pound out the homework. Because it's not quite. Almost done, but not quite.
This is a homework question.
Well, one of the homework questions is do all 4 to 1, and then do. Aha, that's why I made it shorter.
The calculated question, so it's like 25 minutes.
I know. Because having you guys log in and discuss the calculators, it is what it is, whatever. Okay, important part. This is a dot. If it was an open circle, that means something else. If your friends are in Algebra 2, this is not the same thing. But we're not learning compositions.
Open circles, I think?
This, if you have an open circle like that, it's called Fogg and Goff. Right. Fogg and Goff.
Alex, yeah.
Fogg and Goff.
I just got
No, I just saw the log.
Log is log, L-O-G, but Fogg is F of G of X.
So do we have to distribute that?
Sorry. So this is literally F of X times G of X. So you're multiplying these two together. So you're taking 3x squared minus 2x plus 1 and multiplying by x minus 4. Notice there's no plus or subtraction sign in between the parentheses. So therefore you know you're multiplying. Now, you factor it out. No, we want to like multiply them together. So we can distribute. That's option 1, right? You can take this and distribute out, distribute to every single term. And I'll show you what that looks like, and then I'll show you a shortcut that may or may not help you. So, x times 3x squared, 3x cubed, minus 2x squared plus x. So, I just did those 3 multiplications. Now, I'll do these 3 on the top. Negative 12. Negative 12x squared plus 8x minus 4. Combine like terms, I only have one cube factor. Negative 2x squared minus 12x squared is negative 14x squared. Plus 9x minus 4. Okay, this is the answer, but now maybe that's a little confusing, right? Distributing all of these across. Let's try maybe an easier way. So, this is the way one of my calculus students showed me that they do it.
No way. Like synthetic or something? That's how I do it.
So, makes it so you don't miss any of the multiplication. Did you say that's how you do it? Pretty sure that's how your brother does it.
It's not faster way, it's just like more accurate.
It's a different way.
You could see it like cleaner.
Yes, it's a different way of doing it. You get the same answers. So, if we multiply, we get 3x cubed minus 2x squared, positive x, negative 12x squared, because you're multiplying negative 4 and like negative 2x, right? So you get positive 8x. And you add diagonally, yeah. So then we end up with 3x cubed, right, minus 12x plus 9 minus 4.
And it's like straight across. That's
Diagonal.
If you have to do this with
But you have to be careful, because what if I had like an x squared minus 4? It wouldn't just be adding diagonally. You would have to make sure, right? So you have to make sure you're only combining like terms. Otherwise, we get the exact same answer. Okay, Ashton, you had a question?
If you have if you have double digits, you have to slice them in half again. So
Double digits?
Yes.
Don't know what you're meaning, double digits.
Like what if there's 13 there and then times like 11? Or I guess that would work. Oh no. Oh no, it wouldn't.
13 times 11?
Yeah, it's like 13x squared times 11x.
That'd be fine.
Oh, that would. I guess.
Yeah, you just multiply the coefficients and the exponents.
Oh.
Okay, so that shows you 2 ways of multiplying. When you're taking trinomial by trinomial, 3 by 3. Oh my gosh, you get 9 terms. You have to combine like terms. Yikes. So that's a shortcut way. All right, let's try the next one. Now we're doing f over g of x. So what this is you're literally taking f of x, dividing by g of x, as long as g of x is not equal to 0. Okay, so what this
Do
looks
they
like.
do that often? Do they give us G of X equal to 0?
Well, as long as the bottom can't equal 0. That's all it's saying, right? You can't have the bottom equal 0. So you have to state the restrictions. So here we have 3x squared minus 2x plus 1. And I'm dividing by g of x. I'm sorry, yeah, which is x minus 4.
You do it long division?
Well, let's see. If the top has an x minus 4 factor, we're good. But otherwise, like, that's it. You could leave it this way.
I can't.
Yeah, you can leave it this way. Well, let's make sure. Can I factor this any further?
No.
Yes. Wait, plus 2. Wait.
Well, if you move the 3 over, what adds to negative 2 multiplies the positive 3?
What?
2 and 1.
No.
So it's prime. No.
That add to 2 and
Add to negative 2, multiply to positive 3.
Okay, but like.
There's nothing. So imagine, hold on. Ready? Imagine x minus 4 was a factor on top. I could cross it out. I could simplify. So if I can't simplify this, I can just leave it. I can't simplify this, right? X minus 4 is not a factor because we can't actually factor this at all. We're almost done. So we write it. We know it can't be simplified, and then we state the restrictions on our domain. So the bottom cannot equal 0. What x value makes the bottom equal 0?
plus positive 4.
We can't have the bottom equal to 0. So to make sure we know what to do, right, we take this bottom, x minus 4, set it equal to 0. When x equals 4, the bottom would be undefined because you would be dividing by 0. So we say x cannot equal 4, and that is your answer, the restriction, right? You have to include the restriction. Okay, now your question.
So you don't want us to like solve it? Like.
I can't simplify at all. I'll just get a quotient at the end. Yeah. If it goes evenly, then I could simplify it, but this doesn't simplify. I'll end up with a quotient, and that's now better than what I'm at now, you know? I don't want to make this more difficult.
So, like, for the most part, are these kind of things with, like, at the version or whatever, is it gonna just, like, be...
A lot of times it's not going to be simplifiable. A lot of times you won't be able to simplify it. Just depends. You have to look. Can you simplify it or not? Either it's a yes or no. Okay, I want you to try number 1 on your own. On the next page, try number 1, and then we'll go over it. Try number 1.
So it wants to find all 4.
Yep. When you're done with number 1, I want you to try number 2, and then it'll be time for homework. All right, give you some solid time for homework. Okay, when you're done, I want you to look at what I wrote in red and tell me why is that wrong? Why is this wrong? This part. Think about it. Don't say it out loud, but only when you're done with number 1. Think about why. Why is what I did wrong? Okay, why is the red part wrong? Anyone have a good answer? Or is this what you did? So if you think about it, right, if you think about it, you have to do the 8x minus 3 before you can divide by 4x plus 5, right? That's why we can't cross it out, because order of operations, you have to do the addition before you can do the division. Now, if everything had a factor of 4 in it, I could divide everything by 4, but I can't. I can't do over here. That's wrong. Right? If you draw parentheses, it makes it a little clearer. You have to do parentheses before you do the division. You can't just cross out numbers like that. Okay. Do we have questions on number 1? I boxed all the answers. There's 4 answers. Because there's 4 things we're doing.
So we don't have to simplify it?
This is simplified. I can't simplify that at all. I can't simplify that at all.
Okay, so that's the right answer.
Yeah, that's it.
What's negative 5 over 4?
X can't equal negative 5 over 4. That's the restriction, because it says state the restriction, right?
Did you state the restriction for all the others?
I don't have restrictions on the others because I don't have them on fractions. Whenever you have a fraction, you can't have the bottom equal 0. So whenever I'm dividing, I have fractions, and then I see it can't equal 0. Like here, I have a fraction, the bottom can't equal 0. So you set the bottom equal to 0 and say X can't be that number. Because if the bottom equals 0, you're dividing by 0, and that would be undefined, right? That's why we say the restriction here. Okay, do you guys just want to, do you want to do number 2, or do you just want to go straight to homework? All right, cool. So you have 12 minutes. You could knock out multiple parts of homework. We'll end here.